In this video, we are going to discuss the response model, which is a statistical model that captures the relationship between the past marketing efforts and the past company outcome. Right. In particular, for the case today, we try to investigate the relationship between the marketing efforts for four locations, location 1, 2, 3, and 4, and the company revenue. And at the same time, we also take into account the time factor. Basically, this time factor will consider the natural decline trend in revenue that come from competition, that come from the market change. Let's load the required package. Good. And remember, we use this function quite a few times. We try to see the values in normal format and prevent the scientific notation, which makes our interpretation a little bit easier. So let's run the code. All right, next, let's open our data file and save it in a data frame called df. If you successfully load the data file, you will see we have 60 observations with 6 variables. Now let's check the column names of our dataset. So we have 6 columns: revenue, location 1, location 2, location 3, location 4, and the train. All right, next, let's summarize some basic stats for all the columns in the dataset. All right, so if you look at this one, in the first line, you will see the scale for revenue, the first location spending, the second location spending, the third location spending, and the last location spending is in terms of money, right? In particular, we have the trend column, which range from 1 to 60. What does it mean? Basically, in this case, the company collected data over 5 years, and 1 to 60 means 1 to 16 months. So the time will be counted monthly. That's it. Now let's have a look at the data set. So you see all the columns are in monetary values. And for the trend, we have 1 to 16 months. Right. Before we do something officially for response model, let's see how the revenue trend looks like over the last 5 years or over the last 16 months. Okay, so let's use ggplot to plot the trend. In the first line, basically we use the data from df and we want to map the value of the trend to the x-axis, right? And we want to map the value of revenue to the y-axis. So we type revenue rate. Great. If you look at this trend plot, you will see overall the company revenue declined over the last 60 months. All right, come back to the theory. The response model is quite similar as the linear regression model. The only difference is the inputs and the outputs are converted to log values, right? Good. So let's convert the relevant variables to log values, okay? All right, right here, basically we just convert each column to log value. So in the first line, we want to convert the revenue column to log value of revenue. And I just use the same name of the column and paste it here. All right. And let's do the same for the second column, which is the spending for the first location, right? This is the spending for the second location. This is the spending for the third location. This is the spending for the fourth location. Great. Now, I suggest you run all the code at one time. Do you know why? Because if we run each line more than once, we will compute the log of the log. For instance, okay, if I run this code one time, yes, we compute the log of revenue column. But if we run it one more time, then we will compute the log of revenue, right? Right. And now let's check the data frame. This is how it's look like after we converted all the variables to log values. Great. Now, everything the same as it is in the linear regression model. So right here, what do you think? How we specify the regression model? Remember, if the data frame look like this one, we have the outcome variable in the first column and the rest are the independent variables. Then we can specify the outcome revenues, to the side, and that. And we can run the model already. Great. So we save the model result in the object fit. And if we want to see the result of the model, we can summarize fit. Great. Very good. All right, so we have the result from our model. So let's try to interpret the meaning of the coefficient, given that we know that all independent variables here are significant. All right, so let's try to interpret the meaning of the spending for the first location. What does it mean, 0.34? All right, it means that 1% change in the marketing effort for the first location will lead to 0.34% increase in the revenue because this is the positive coefficient, right? And please try to interpret the meaning for the other coefficients for other locations marketing efforts. The only thing I would like you to focus and challenge yourself how to interpret the meaning of this coefficient. Remember, we didn't convert the trend column to log value. It means that 1 month forward, the revenue of the company will decrease by 0.001%. And this interpretation aligns with what we see on this revenue trend over time, right? Good. Now we already have the result model. Okay, all of this we call the result model. We would like to extract the estimate from this result model. Okay, and for now we use the tidy function. The tidy function can help us to extract the estimate from the regression model beautifully. In particular, we already saved the result model in the fit object. We just tidy the fit object. That's it. And we would like to tell R to round all the estimates and keep all of them with 2 decimal places, right? So we would like to have 2 decimal places right here. Now let's run the code. Good. And let's print the estimate data we just created. Very good. Okay. Actually, this estimate data frame is the same as what you see in the model result, right? It just looks neater and more presentable. Great. All right. So from the response model, we already know the coefficient for each location, right? So then as a marketing manager, how would you allocate the resources? All right. The idea is we just take the coefficient of each location divided by the total coefficient of all four locations. That's it. For instance, for location 1, we take beta 1 divided by beta 1 plus beta 2 plus beta 3 plus beta 4. And the same thing for other locations. That is the mechanism how we allocate the resources. Great. All right, having said that, having the coefficient for four locations is important. Now, let's do one step further. Let's extract the coefficients for four locations only. All right. So right here, let me show you how I proceed with the code. Okay. So if you use the code summary fit, so basically you got the whole model result, right? What happened if you add a dollar sign and you call coefficients? In that case, then you will get all estimates, right? Like this one. And we only want the coefficient, and the coefficient is the first column in this table or in this data frame. All right. And we can specify. Okay, so this is what we want for the first line of codes right here. So in the first blank, basically that is the fit. And this is the coefficient. Great. And the next line, basically we sum all coefficients belonging to four locations, right? So, so basically we only take into account this one, this one, this one, and this one, right? Now we're almost done, okay? So the next step, basically, we try to compute the proportion of each location's coefficients over all coefficients together, right? So right here, I use a new function called turbo, okay, to compute the proportion of each location. In particular, in this code, in the first column, I create a vector called location. It stores the name of four location. That's it. Okay. And the next line, basically, I compute the percentage of coefficients for each location. So we take the coefficient of each location divided by the total or the sum of all coefficients, which we already computed right here. Okay. So it is blank. It is total. Now we can run the code already. Good. And we can print the allocation data frame that we just created. Right? You see, the first column we have location. We store the name of four location. The second column we have percentage. We store the resource percentage for each locations. All right. Now we can go one step further to plot the resource percentage for each location. All right. I give you some hints right here. You can use the hint to prepare the ggplot, the bar plot. All right. So in the first blank, basically, we need to specify what is the data set. And the data set we want to use is allocation. right? And on the x-axis, we want to see the names of location. So we want to map the location value to x-axis, which is location, right? And on the y-axis, we want to see the percentage for locations. So we want to map the percentage column to y-axis. Right. The next blank, what do you think? Field. Basically, we want to color each location by a different color. That's it. And we will use the value from location for it. Right? In the next in the next line, basically, we want to tell R that we want a bar plot. That's it. All right. In the next line, we want to tell R that please add the label for each bar of the location using the percentage value. For instance, for the first location, I want to see the resource percentage, which is 38.7. So right here, we would like to tell R use the value from the percentage column, right? And the next code, basically, we want to add the title. Now we can run already. It. All right, great. So of course, we should use the power of ggplot to present our findings in the marketing context. All right. So as a marketing manager, you should analyze why you should spend that much for the first location and vice versa, why you should spend that little for the last location.